also we are going to predict the crop failure. That is the major application what we have seen with respect to agriculture and also with respect to the energy consumption, right? The prediction as well as the management of the energy demand and the utilization of the rationalism. That is also one of the concepts what we are dealing with respect to the applications of AI. And also AI plays a very important role with respect to the financial sectors in for AI-based credit underwriting or for AI-based credit card analysis, fraud detection, and with respect to the artificial intelligence in healthcare, there is a predominant applications we have seen with respect to the healthcare. For example, timely epidemic predictions. For example, you might have seen there is a diagnostic predictions with respect to the treatment. How can we optimize the health resources? And with respect to the logistics, with respect to the MSMEs, with respect to the improvement of the competitiveness, right? In each and every field with the usage of AI. This is one of the slide what we have got from the NASCOM during the year 2020. Right, there is an improvement with respect to the production of the crops from the farmers, and there is an 150 GW renewable energy capacity is used, and 150 technology centers with respect to the AI has developed, and around 150,000 wellness centers are evolved, and around 100 plus lakh credit cards or credit loans from the MSME is introduced. These are all some of the applications where we have seen the concepts of AI in the recent eras. As we all know, AI is not just an algorithm or it is not just a model. Right? Initially, we start with the data acquisition process, later on the data pre-processing, or next we go and deal with respect to the concepts of a future engineering and the evaluation as well as the experimentation process. As you all know, whenever we talk with respect to the concepts of an AI, we start or we make an intelligent machines. We start creating an intelligent machines. How and why do we need to create an intelligent machines? In the sense, to automate the work required, we are mainly focusing on the concepts of an AI. It was developed, the concepts of an AI was introduced by John McAfee in the year 1950. That is how the concepts of AI started evolving. Later on, we start talking with respect to the concepts of the machine learning, deep learning, and what's the major difference we have seen with respect to the artificial intelligence or with respect to machine learning or with respect to deep learning. Whenever we talk with respect to an artificial intelligence, we are mainly going to create the intelligent machines by mimicking the human behavior. That is what we do it with respect to an AI. Later on, when we start talking with respect to the machine learning, in case of a machine learning, we use the concepts of a statistics. Either it can be with respect to the inferential statistics, or it can be with respect to the Bayesian statistics, or it can be with respect to the frequency statistics, using the concepts of a probability, using the concepts of linear algebra, calculus, tenses, right? Using all this, we start predicting the data. That is what we use the concept of a machine learning. And later on, we start mimicking the human brain. When we start mimicking the human brain, we use the concepts of a deep learning. What does that deep learning indicates? As I said, we mimic the human brain. In the sense, our brain is full of neurons. Neurons are the cells which are connected to the which are interconnected to form our brain. Each and every cell of the neuron is represented in the form of a artificial neuron, and each and every neurons are processed to form the concepts of a deep learning. In the sense, here we use the multi-layer neural network architecture. What does that multi-layer neural network architecture indicates? Initially, initially we start with respect to the input layer. Followed by the input layer, we have a set of hidden layers, and we have an output layer. That is what we call it as a multi-layer neural network. That I'll be going to brief out in the coming slides. Let us first discuss the applications of an artificial intelligence as well as a deep learning in the today's generation, and later on I'll be going to talk with respect to the concepts. As I said, how big companies as well as the deep learning startups use AI. You might have observed in each and every applications, either it can be with respect to the health care or with respect to the usage of AI by the Google, by Amazon, by Microsoft, by Facebook. Each and every companies are going behind the concepts of AI. What is the reason why AI is playing a very important role in the 21st century? How AI is boomed as one of a specialized trend or the specialized technology we can say in the era of 21st century, right? When we talk with respect to the Google, for example, if I consider any of the applications with respect to the Google, either it can be a Google Translator, or it can be a Google Maps, or it can be the each and every applications what we are using, the voice message what we fed into the system, right? Each and every applications which is designed by the Google is based on the concepts of artificial intelligence. Nowadays, we can say the Google is a completely transformed AI-based company, right? In the same way how this Amazon, for each and everything, for example, for the usage of a chatbots, for the usage of the Siri, or for the usage of the Alexa, for each and every applications, right? All these companies are completely dependent on the AI. And also, you might have observed the Tesla, the self-driving cars, what they have invented is also based on the concepts of AI, right? These are all the various applications what we have seen AI and where we have used AI, right? And most of the startups are using AI. This is one of the example which is indicating the gesture recognition, the hand gesture recognition. That is also one of the applications where we have used the concepts of AI. Right. For example, when we need to recognize the gestures of the deaf and dumb, that is one of the major applications what we have seen the usage of AI. Right. This is the automatic self-driving cars. That is what the image indicates. And next to that, I said like we were talking with respect to the concepts of a machine learning, or we were talking with respect to the concepts of a neural network, or we were talking with respect to the concepts of a deep learning. When I talk with respect to the machine learning itself, as I said, we use the mathematical foundations. Either it can be the concepts of a probability, or it can be the concepts of the statistics, or it can be the concepts of the tensors, or it can be the concepts of the linear algebra, calculus, right? Using all these concepts, we are going to predict the data with the help of the machine learning algorithms. That is what a machine learning do, right? And when we talk with respect to an artificial intelligence, as I said, we are going to mimic the human brain. In the sense, here, each and every data what we process will be considered in the form of an agent. Agent is one of the thing or an entity which perceives the surrounding environment. What does that perseverance indicates? It observes the surrounding environment, right? Based on the observations with the help of the senses, right? It is going to take certain actions with the help of an actuators. The basic AI machines, which was developed in the year 1950s by Norway, was a laundry folding machine, which was developed by the Texas AT&T laboratory in the year 1950s. Later on, they started improving the versions what they have developed, and it has like proved in the applications of AI is proved in various aspects. You can have a look at this example as I was discussing with respect to the concepts of an AI and machine learning. Right, when we start talking with respect to the concepts of a machine learning itself, either it can be the concepts of a supervised, or it can be the concepts of unsupervised, or it can be the concepts of a reinforcement. When we talk with respect to the supervised, we provide the data to the system. Based on the data provided, or based on the knowledge base provided, it is going to predict the data. And when we started talking with respect to an unsupervised, we are going to group the similarity or cluster the data based on the similar objects. When we talk with respect to the reinforcement, there is a human feedback. Along with the human feedback, it is going to predict the data. These are the different types of the machine learning concepts what we have discussed. And next to that, we started talking with respect to the concepts of a deep learning. Before discussing the concepts of a deep learning, let us have a look at a neural network. As I said, in case of a neural network, we are going to mimic the human brain. How are we going to mimic the human brain? For example, this is one of an example which is showing the uh, uh, indication of the neuron, right, which has the dendrites, which has the cell body, which has the nucleus, axons, as well as the synapses. Right, these are the inputs what we have given to the computer, or what we have given to the artificial neuron. With the help of a dendrites, we can give n number of inputs, right, and that will be like the inputs will be given to the summation function, the output of the along with the bias. The summation function output will be given as an input to the activation function, and the activation function output will be given to the error function. And here, with respect to the error function, we are going to check whether the input what we have obtained is equivalent to the desired response. If it is equal to the desired response, we are going to consider that as the predicted output. Otherwise, the error function will send back to the neurons to update the weights as well as the inputs accordingly. Right. And And I was talking with respect to the inputs as well as the summation functions. What are the inputs I provide here? For example, you can observe with respect to this picture, right? I'll be going to provide certain features as an input to the system, whereas the n number of the inputs will be provided to this, and the output of this will be the summation function. Along with that, it will be sent to the activation function. The activation function can be of a sigmoidal activation function, or it can be a ReLU, or it can be a tanh, or it can be a pairwise, or it can be a leaky, or it can be the leaky ReLU. Various activation functions we have, or it can be the tanh. When I talk with respect to the step function, it can be between the 0 and 1. When I talk with respect to the sigmoidal or the logistic activation functions, that is what the threshold we use, 1 by 1 plus e to the power of minus x. When I talk with respect to the tan h, e to the power of x minus e to the power of minus x by e to the power of x plus e to the power of minus x. That is what we use a formulas to find the activation function value with respect to the particular neuron. Next to that, we started talking with respect to the ReLU. In case of a ReLU, we'll be going to consider the maximum of a zero with respect to the x input what we have taken, and the and later on we start talking with respect to the concepts of uh, gas RBF, where that is also one of the activation function what we use. And why do we use this activation function? To produce the output in the given threshold, right? That is what we are going to do with respect to this. And this is what the output we have got. This is with respect to the single neuron. And when we are talking with respect to the multiple neurons or the multi-layer perceptrons. In case of a multi-layer perceptron, we have one input layer and the set of our hidden layers and one output layer. These hidden layers plays a very important role. That is where we are making a difference between with respect to the use of CNN or use of RNN or use of any LSTM or any of the algorithms what we seen with respect to the deep learning. For example, when we are talking with respect to this, for example, if I have only one hidden layer, the amount of the processing operations what I do it here is less. If I have a multiple hidden layers, in case of a multiple hidden layers, for example, it can be a pooling layer, it can be a max pooling layer, it can be a soft max layer. Like that, each and every layer plays a very important role. That is what we talk with respect to the convolution neural networks. And next, if we are having a feedback layer, then we call it as the recurrent neural network. And if only it is a feed forward layer, then it starts from the input and it goes till the output. That is also one of the layer what we were talking with respect to it. And when we talk with respect to the multi-layer perceptron or the multi-layer, in multi-layer perceptron, you'll be having multiple hidden layers. And these are all the supervised layers, and this is what the supervised operations we perform with respect to the deep learning. And next to that, we start talking with respect to the RBF. RBF is nothing but the radial basis function network. In case of a RBF, we start with the lower level dimension of the data that will be converted into the higher level dimension data in the hidden layer, and where hidden layer works as an unsupervised, and the unsupervised data will be converted into the linear form at the output layer. In the sense, RBF has one input layer, one hidden layer, and one output layer, whereas the multi-layer perceptron can have many number of the hidden layers based on the requirement of the application. And in case of a single layer perceptron or the single layer neuron, this is how the single layer neuron works. You have a n number of the inputs, you have the summation function, you have the activation function, and you have the output. This is with respect to the basic structure of our artificial neural network and the deep learning. And what are the applications we have seen with respect to this? Initially, we can use this to perform an image recognition operation. For example, you can observe this is the input image. The input image is represented in the form of a pixels. Usually, the pixels will be converted into the grayscale based on the intensity, right? Why do we convert the RGB to the grayscale? Because to process that operation, the processing of the grayscale image is quite easier compared to the RGB. The intensity value, the whatever the value we have given for each and every pixels, right? Based on the intensity value, we are going to perform the recognition operation. Right, you can observe here, this is one of the visual cortex. How are we going to represent? Or this is one of the retina. How are we going to represent? In each and every layer, whatever the pixels we have taken, the edges, the shapes, the primitives, the postures which is required will be identified in each and every layer, and the output will be predicted in the final layer. That is what the deep learning does or the deep learning do. This is one of an example which is indicating there is an OCD with respect to the brain, or the brain is a healthy. This is also one of the applications what we have used with respect to that. And you can observe here, this is the hand recognition system where we are going to recognize the numerics using the concepts of a deep learning. right? And this is what I was talking with respect to that. You can observe the inputs will be fed, and in each and every layer, it will be predicted, and the output will be represented in the final layer. This is one of an example which is representing the hand recognition system. And you can observe what is the major difference. The annual maintenance of the fastest supercomputers is quite huge compared to the maintenance of a human. Right, and you can also observe, for example, how the supercomputers plays a very important role. Right, this is a very bird which was able to identify the uh, 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 like for example, if there is any storms that was identified 2 decades prior, it was able to identify before, like 2 to 3 months prior to the um, major storm occurring. Right, that is how the natural circumstances were identified using this bird. But the same way we are going to make use of our computer to predict the major storms in months, right? In months in advance. This is also one of the example which we were using the bar-tailed goat. This is one of the bird which was traveling from the Alaska to Tasmania without any Google map, right? That is also one of the natural um, circumstances what we have seen, and that is how this maps and the Google devices are designed or developed, right? And that is what we were talking with respect to that. As I said, like AI can be seen as a broader umbrella, and the machine learning is one of the subset of an AI, and this deep learning is the subset of the machine learning. As I said, AI is creating an intelligent machines or mimicking the intelligent machines to work as a human beings or to behave as a human beings. And the subset of the machine learning or the subset of an artificial intelligence is the machine learning, where we are mainly going to talk with respect to the statistics as well as the probability concepts for the prediction of the data. With respect to the deep learning, we are making use of the multiple layers by mimicking the human brain, right, for the creation of the for to work with respect to the huge amount of a data or the huge set of a data. For example, let us take a basic examples of the images which is stored in your phone, right? Initially, the data was in the form of a GB or the KB or MB. Now the data are in the form of a GB. I need to process each and every data. How will I be able to process the data? By creating a multi-layer perceptrons or by creating the multi-layer neural network, I'll be able to perform such operations. In the sense, when the data is huge, when the number of parameters are huge, we use the concepts of a deep learning, right? And when we are predicting the data for a small data sets or for some supervised data sets for some unsupervised data sets where the statistics plays an important role in the prediction, in such cases we use the concepts of a machine learning. And also we have some advanced concepts, or either it can be the descriptive analysis, the predictive analysis, the prescriptive analysis, and or it can be the speech analysis, the spatial, the video analytics, right? These are also some of the advanced topic what we have seen with respect to an AI. And these are all the use cases what we can find. We can find AI with respect to the stock prediction. We can find with respect to the connected cars. We can find with respect to the stream analysis, financial risk management, fraud detection, data and the identity protection with respect to the logistics, with respect to the smart grid. These are the major applications where we have seen the concepts of AI. And also, I was talking with respect to the types of an ML. It can be a supervised, or it can be an unsupervised, or it can be a reinforcement learning. When we talk with respect to the supervised, right, either it can be the concepts of the regression or it can be the concepts of the classification. That is what we do it with respect to the supervised learning. When we talk with respect to the regression, it can be a linear regression or it can be a logistic regression. We have a various different types. Whenever we are performing a weather forecasting operation, whenever we are performing the market forecasting operations, whenever we are performing some of the growth predictions, right? In all these cases, we use the concept of a supervised. And in case of, for example, image recognition, image classification, image detection, right? In all these cases, we use the concept of classification. And when we talk with respect to the unsupervised, when we need to group our similar items or when we need to reduce the dimensionality of the given element or the given data, in such cases we use the concept of an unsupervised. Clustering, you can make use of the clustering in recommendation system. For example, with respect to the customer segmentation or with respect to the targets marketing. We can also make use of the dimensionality reductions with respect to the feature reduction, with respect to the feature analysis, with respect to the data visualization. When we talk with respect to data visualization, either you can make use of a Power BI, or also you can make use of the concepts of a jump statistical discovery, or you can make use of the Tableau for the visualization representation. What does that data visualization representation indicates? Representation of the data in the graphical manner by using the forms or by using the charts, by using the maps, by using the graphs. Right. For example, is the satellite image what we have taken, right? The images what we have captured, it will be represented in the form of a maps or the geographical information system. That is also one of the example representing the data visualization data. And this is what I was talking about, some theoretical data I have given. How does this work and what are the different types of the regression algorithms we have? Right. Most commonly used is the logistic linear as well as the ridge lasso and the support vector machines. These are the most commonly used different types of the regressions. And when we talk with respect to an unsupervised, as I said, clustering as well as the association plays a very important role. You might have heard of the k-means clustering, right? Or a priori. These are the different types of the clustering algorithms what we have used. And when we talk with respect to the machine learning, initially we take the raw data, right? The raw data will be pre-processed using the data cleaning as well as the feature engineering. This is what we do it with respect to the feature engineering processing. The initial data can be for example, if it is an image, we pre-process the data, we remove the noise with respect to the data, and we remove the unwanted edges or the data which is not required for the processing will be removed using the feature engineering. Next, the data will be sent for the identification, the classification, and at last it will be sent for the detection or the recognition system. That is what we do it using the concept of the machine learning. And nowadays the people are making use of the concepts of auto ML, that is an automative ML, where most of the concepts, for example, if this is the data will be sorted initially, it will be arranged, it will be presented in the form of a visual, and it will be explained with the story, and the actionable will be converted. This is what we are going to do it using the concepts of an auto ML. And these are all the algorithms, like how we use and what algorithms to use and when to use. For example, it can be a gradient descent. The gradient descent is one of the algorithm which is most commonly used for the purpose of an optimization. We have a support vector machines, which is majorly used for the classification. We have a k nearest neighbor, which is mainly used for the um, clustering, and we have a logistic regression as well as the different types of the regression which is mainly used for the classification purpose. These are the different algorithms or the different types of the algorithms with respect to the machine learning what we use.
Excuse me, ma'am.
Yes,
Ma'am, reinforcement learning, ma'am. About
you
the
wanted to know
reinforcement.
about the concepts of reinforcement learning.
Yeah,
And
yes,
what do
ma'am.
we do with respect to the reinforcement learning? As I said, we have three different types of the learning, right? The first one is the supervised learning. Supervised learning in the sense we have given a knowledge base. Knowledge base is nothing but the data set, right? We are going to predict. For example, in the data set itself, we'll be having the 80% of the training set and the 20% of the testing set, right? The testing set will be going to compare with the training data set for the prediction of the data. That is what we do it using the concepts of a supervised learning. When we talk with respect to an unsupervised learning, in case of an unsupervised learning, for example, you need to identify the similarity between the group of elements what you have. In such cases, what do? We group the elements based on the similarity, right? Using the algorithms of a k-means or a priori. That is what we talk with respect to an unsupervised. And this reinforcement learning is quite different compared to these two. As I said, with the help of an artificial intelligence, right, we artificial intelligence, we are mimicking the human brain with the help of a human feedback. In the sense, we talk with respect to concept of an agent. I was talking with respect to the concept of an agent. What does an agent do? The agent perceives the surrounding environment. This reinforcement learning will also be considered as a semi-supervised learning. What do we do with respect to this semi-supervised learning? We perceive the surrounding environment. Perseverance in the sense we observe the surrounding environment with the help of an act, with the help of a senses, right? And we will take the human feedback and we will act using the concept of an actuator. That is what a reinforcement learning will be done, right? How that is how the reinforcement learning will be used. In the sense, in case of a reinforcement learning, we take the human feedback whenever we are going to process the data in the form of an agent. That is also considered as an example of a semi-supervised machine learning. I'll be going to talk with respect to the concepts of reinforcement learning again with respect to generative AI. Is that clear, madam?
Yes, thank you, ma'am. It's clear, ma'am.
Oh, oh, fine. Thank you. These are all some of the auto ML tools what we use in the different companies. For example, either it can be a Google Cloud, or it can be with respect to the excessive, or it can be with respect to the auto scaler, that is the scikit-learn, right? This is one of the commonly used machine learning tools in the recent days, right? And we also have some of the operations, MLOps. You might have heard, like machine learning operations. What do we do? Right. Either it can be with respect to the business analysis, or with respect to the data pipeline, or with respect to the batch processing, or with respect to the online processing. Online processing is nothing but the real-time processing, what we do with respect to the MLOps operations. Right. These are all some of the major operations what we predominantly do with respect to the MLOps. Either it can be as a data scientist, or it can be as a data engineering, or it can be as a business stakeholders, or with respect to the implementation. For each and every operations, we use the concepts of an MLOps, right? And also these are some of the software engineering developments as well as the MLOps tools what we have seen in the recent days. Usage of a Python, usage of a Jupyter Notebook, usage of a Colab, usage of a Tableau, usage of a Power BI, usage of Amazon Web Services. It's some of the tools what we are using nowadays for the AIML applications. And these are all the people whom we can say like mainly working predominantly from last 10 to 20 years on the concepts of artificial intelligence and machine learning. This is a basic introduction what I was about to discuss with respect to the concepts of mm, AI as well as the ML with respect to some concepts of a deep learning. Right now, I'll just talk with respect to the concepts of generative AI, because as we have seen, the generative AI is playing a very important role in each and every field. Why this generative AI is very important? How the generative AI is changing the life of our people every day, right? If you have any queries with respect to artificial intelligence, machine learning, and deep learning, we can take it in the end. Shall I start with the concept of a generative AI? Or if you have any queries, you can talk to me now.
Proceed, madam. Proceed, madam.
Okay, fine. Thank you. Now, as I said, we were predicting the data, or we were inferring the data when we were talking with respect to the concepts of machine learning or the deep learning. In the sense, the prediction can be a credit card prediction, or it can be any of the disease predictions, or it can be with respect to the crop failure predictions. Like that, we were predicting based on the data what we have. Right? We had the data. With the help of the data, we were able to predict the output, or we were able to infer the output. And also with respect to the concepts of a machine learning, we were finding out the output based on the error corrections what we have taken. The error correction rule works based on the output what we have obtained from the activation functions, and based on that we are going to infer the data. Either it can be with the help of a single layer perceptron, or using the concept of a multi-layer perceptron, or using the concepts of the ARBF. When we have a huge set of a data, we take more number of hidden layers, and we process and we predict the data with the help of a CNN or with the help of RNN, like that. And when we have a continuous data, that is also one of the major applications what we are seeing with respect to the deep learning. For example, the time series as well as the financial analytics. What do we do with respect to the time series and financial analytics? We take the continuous data. For example, the basic example of the stock prediction, or the examples of the weather forecasting. Those are the basic examples what we have seen with respect to the time series as well as the financial mathematics or the financial analytics. Now, I'll be going to talk with respect to the concepts of a generative AI. In the sense, Here, we are not going to predict the data or we are not going to infer the data. Take your phones and just check with the web by typing this person doesn't exist. Right? You go to that URL and check this person doesn't exist. It will take you to some website where it is going to create the automatic images. See, there is no images or there is no person exists of this type. Any image, if you refresh, it is going to generate some other image, right? Like that, in the sense, in each and every case, the images are generated. Here, there is no gender specified, there is no age specified, there is no ethnicity specified, nothing is specified, but it is going to automatically generate the images. How does this work? How the concepts of a generative AI plays a very important role with respect to this. Right. Here, we are going to talk or we are going to discuss with respect to this generative AI and the concepts of an LLM. Is that clear? In the sense, here we are not going to predict any data or we are not going to infer any output. We are generating the data. The data can be of an image or the data can be of a text or it can be of a musical generation. You might have observed people are using a chat GPT every day. Either it is for a good cause or for a bad cause. We don't know, but everybody uses a chat GPT for the generation of the data. In the sense, wherever you find, there is no person exists of this type. But here, with the help of a generative AI, we are able to generate the data or we are able to come up with the new data, right? That is what we are going to do using the concepts of a generative AI. What do we do? How does a generative AI plays a very important role with respect to the current technology? When we were talking with respect to generative AI, as I said, we are going to generate the new image or a new text, or it can be a new data, or it can be a music. Each and every data will be created or it will be generated automatically. How? How generative AI plays a very important role. Right. As I said, for example, let us take an example of a basic chatbot. What do we do with respect to the chatbot? We provide certain inputs. Based on the inputs, the data will be generated. For example, if you are using a Swiggy or if you are using a Uber or any of the applications nowadays, right? They are all predefined or they are all pre developed. You are not going to make use of, or the human will not be sitting and will be answering the questions. It will be done by the machine, and the concept which is used behind this is a generative AI. For example, you can observe here, this is who designed the street layout of a Washington DC. This is one of the question which is asked to the chatbot, and it is going to provide the required answer. How it is generated, how it is created. That is what we are going to do it using the concept of a generative AI. In the sense, for example, if you consider a map, right, nobody is sitting and telling you to divert to the right or to the left using the map. The concepts of a generative AI will be used to perform this operation. That is also one of the basic examples where the generative AI concepts of the large language modeling is used. What is this large language modeling? What is that? What are the different types of the large language modeling we have seen? Either it can be the usage of a GPTs, right? Or it can be the usage of the birds, or it can be the usage of the lambda, or it can be the usage of the flan. These are the different types of the large language modeling, which is mainly working with respect to the processing or the generation of the huge amount of our data. That is what we talk with respect to the large language modeling. And what does this prompt indicates? The prompt is one of, for example, here I'm talking with respect to the text. Prompt is a text what we give to the system for performing its operations. In the sense, where is this gray mode located in the solar system, right? That will be given. This is one of the text or an input. Input is called as a prompt. Prompt will be given to the model. The model is the large language model, right? Why we call this as a large language model is because we are processing a large amount of the information for the generation of the data. That is the reason which is referred as the large language modeling. And the output will be generated here, right? Based on the questions what I have asked, the output is generated here. In the sense, what does that prompt do? Right? What are the use cases we have? It can be used for the essay creation, or it can be used for the summarization, or it can be used for the translation, or it can be used for the information retrieval operations, or it can be used for performing a different actions, right? What is the difference? For example, if you are having a bird which is of 110 hem and you have a bloom which is of 176b, what does this indicate? One second. Sorry. Here we are going to different, or we are going to see what are the major use cases or the applications we have seen using the concept of LLM. As I said, you can make use of an LLM as a summarization part, or you can use it for the translation part, or most probably we use it for the creation part. Right? This is what our LLM is mainly used for. Right. Let us take a basic example of an RNN. RNN is one of an example of the deep learning where it takes recurrent neural network. Right. It mainly stands for recurrent neural network. For example, if I have given an input tea tastes, my tea tastes great. Right. This is one of the input which is or the data which is generated from the RNA. In the sense, the milk is bad. The previous data what I have taken here is the milk is bad. My tea tastes great. Is that correct? No, definitely not. Right? If the milk is bad, definitely the tea tastes bad. That is one of the basic example what I have taken here. Consider the next example. I took my money to the bank. I took my money to the bank. In the sense, this is the river bank which is talking about, not the financial bank. Here also, the RNA is making a mistake for the generation of the task or the generation of the text. How? Why RNN is doing a mistake? Even though we say deep learning is a very important or some of the specialized technology which helps us in solving a large amount of the task. Even though we say like deep learning plays a very important role with the generation of the text or with the usage of a LLM, we are not able to predict the output using the concepts of a deep learning. And also, let us take another example. The teacher taught the student with the book. The teacher taught the student with the book. Right. The book can be of a student's book or it can be of a teacher's book. There is no clarity with respect to the text taken. Right. These are all the basic examples what we have taken to differentiate with respect to the concepts of a deep learning and the generative AI. When they started talking with respect to the generative AI, here we are going to generate the text or we are going to generate the image or we are going to generate the musical data or any type of the information. Nowadays, people are working on a music generation or they are also working on a video generation. Right. Recently, you might have observed there was some fake videos which was generated based on our Modi ji, right? Like that, many fake videos are also getting created. What are the technologies involved behind all this, right? As I said, when I talk with respect to the generative AI, we started making use of this concept of a generative AI from 2020 onwards, right? In the sense, the concept of a generative AI was evolved in the year 2017 by the Google researchers by publishing the paper called as Attention is All You Need. Right, this is one of the paper which is presented or published by the Google research team based on the concept of a transformers. What does that transformers indicates? Transformers are the self-attention mechanism. That is what we call it as a transformer. Based on the self-attention mechanism, right? They have created the concepts of a data generation. This is one of the paper which was developed by the or which was published by the Google researchers based on the attention is all you need. Based on this concept, they are generating the data. They are pre-processing or they are producing the new data. In the sense, based on the concept of a self-attention mechanism. That is what they have presented. This is presented by the people of a Google research team in the year 2017. It's one of the paper which is presented in the year 2017. There is no good textbooks on generative AI. Most probably, there is no textbook I have seen with respect to this. Even for teaching the concepts of a generative AI, I'm making use of this white papers to our students. Right. What does this self-attention mechanism indicates? What does this architecture says with respect to the generative AI. I was talking with respect to the self-attention mechanism. This is what the self-attention mechanisms which we were talking with respect to the transformer. Here, this is the architecture of the self-attention mechanism, or this is the architecture of the transformer. Here, we are going to produce the input data. The input data will be provided in the form of a text, right? That will be processed and that will be given to the LLM model, and that will be converted into the output based on the requirement. The input what we provide will be considered as the prompt, and the entire operation which we have worked will be considered as the LLM model, right? This is what LLM model, and the output what we are predicting is the data what we have seen. That is what we are performing using the concept of a transformer attention mechanism, or using the concept of a self attention mechanism. We are going to discuss this. Now let us have a look at how does this works with the help of some slides. As I said, initially it has the input embeddings as well as the output embeddings, and along with that it has two parts. One is the encoder scheme and the decoder schemes. This encoder scheme and the decoder schemes are used for the generation of the text, and at last we have a softmax layer. This is the basic layers what we can find with respect to the transformers. Right? Why do we use it? We can perform the parallel processing operations. We can we can improve the scalability of that. This is the differences what you can find with respect to the RNN and the CNN. When I talk with respect to the RNN, this is how the operations RNN performs. In the sense, neighboring keywords are mapped to find the output with respect to the RNN. The teacher taught the student with the book. Observe carefully. Here, there is only the neighboring mapping mechanisms will be done using a concept of an RNN. There is no mapping with respect to each and every content what we have taken with respect to the RNN. But with respect to the self-attention mechanism, with respect to the transformer, T is mapped to each and every content. Again, teacher is mapped to each and every content. This is what the self-attention mechanism works. This is how the mapping works with respect to the LLM. Based on this concept, it is able to generate the new content clearly. In the sense, based on the mapping, what they have done, based on the angular difference, that's all, that also I'll be going to discuss later. Based on that, we are going to say how does this self-attention mechanism works. This is, it will be going to map the content based on the self-attention mechanism. This is how it is mapped the content with respect to the input what I have taken. And this is the architecture. The architecture contains these many layers. The input layers, which has the embeddings, and you have two parts. One is the encoder part and another one is the decoder part. This is the output part, and this is a softmax as well as an output part. We'll discuss this in detail now. As I said, the input part, whatever the input we take, the teacher taught the student from the book. We don't know what the book is, whom the book is. Like that will be converted into the tokenization. Why do we need to convert the input characters into the token? Because it is easy for us to work with respect to numericals compared to the characters what we take. So that will be converted into the input what we have taken will be converted into tokens. And next we are going to perform a positional embedding operations. What is that positional embedding operation? This token IDs will be converted by the tokenizer. Next, positional embedding is required to find the distance or to find the angular difference between the elements what we have taken. So next, whatever the data we have taken, that will be given to the positional embedding. The maximum positional embedding what we have taken is of 512 bytes. Right, this is one of the examples what is representing with respect to the embeddings what we have taken. This is what we call it as a positional embedding. For example, student and the book, internet we have, computer we have, and the fox and the fire. Those are all some of the dissimilar elements they have taken. Based on the similarity, the student and the book, we are going to map it. Right? This is what the self-attention mechanism we are performing with respect to this. And we are going to find the angular difference between the words what we have taken. Right? These two are having a less angular difference compared to the other words what we have taken here. Based on the angular difference, we are going to perform the self-embedding. Right? We are going to perform the self-attention or the self-mapping mechanism. The tokens we have converted into the positional tokening based on the angular difference. This is what we are going to do with respect to the embedding form. Right. Next, it will be sent. Next, it will be sent to the encoder as well as the decoder schemes for the encoding as well as the decoding operations of the self-attention's data what we have taken. And It is also going to perform the multi-headed self-attention mechanism. For example, these are the examples what I have taken for the self-attentions, right? Here I have taken teacher taught the student from the book. Here also I have taken, like that we have taken a multiple headed self-attention, and based on the multiple headed self-attentions, it is going to produce the required output. That is what we are going to do it using the concept of a transformer. Input, embeddings, either it can be the tokenizers, or it can be the positional embeddings, or it can be the decoding as well as the encoding operations and the softmax. Right? This is what a transformer does. A transformer can perform a sequence to sequence task. For example, this is the sequence information what I have given. Right? The sequence input will be converted into the required tokenized, and it will be given to the encoder, decoder, and the output will be fetched at the output layer. Right, these are the, based on these mappings, what have taken encoding and the decoding, it is going to generate the text. The whatever the numericals we have generated, that will be again converted into the word form. These are the tokens which is generated at the output. Right. This is in some other language which is converted into the required language. This is one of the sequence to sequence task which we have done with the help of a transformers. And also you can perform encoding as well as the decoding. Encoding, it accepts the inputs, and also the contextual understanding will be done, and it will be producing the one vector per token. That is what we do with respect to the encoding. Decoding, it accepts the input tokens and generates the new tokens. That is what we are going to do it with respect to the decoder. In the sense, encoder accepts the prompts or the inputs with the understanding of that and produces the vector into per token. And next, decoder, it accepts the tokens and generates the new tokens, right? And you can have a different text. For example, if you are performing a translation, if you are performing a summarization, or if you are performing a information retrieval, or if you are generating the data, you can have only encoder models, you can have both encoder decoder models, you can have only decoder models. For example, if you are using a chat gpt, you will be having only decoder models, there is no encoder models with respect to that. That is what the concept of a transformer or the self-attention mechanism works. Next, we are going to talk with respect to the prompt as well as the prompt engineering. Most of you might have listened, or most of you might have heard. People say like the most booming job in the society is a prompt engineering. What is that prompt engineering? The person who is working with respect to the concepts of a prompt. Prompt is the input text what we give it to the system. Right? It will be modeled using the LLM, and the required output will be generated. This is what we call it as a prompt engineering. And also we have three different types of the learning. Either it can be in context learning, or it can be a zero context learning, or it can be one context learning, or it can be a few context learning. In case of a zero context learning or a zero shot learning, we provide zero inputs to the system or the zero references to the system. It is going to generate the data. For example, the most commonly used example is the sentiment analysis. How do we do? How do we provide? How do we analyze the data what we have taken as a positive or the negative sentence? That is also one of the example what we do with respect to the in context learning. And next we were talking with respect to the one shot. Some of the references will be provided for the generation of the text, and few of the inputs will be given. Based on that, it is going to generate the text. These are the three different types of the context learning. Either it can be the zero shot, one shot, or the few shot context learnings we have. And let us have a look at the life cycle of the generative AI. Sir, can I extend for some more time?
Yes, madam.
Okay.
Kindly proceed.
Thank you so much. This is one of the life cycle what we are talking with respect to the generative AI. This is the scope. Scope, in the sense we are going to define the use case. The use case is whether we are using it for the summarization purpose, or we are using it for the retrieval purpose, or we are using it for the translation purpose, or we are using it for the generation purpose. And you are going to choose the model based on the use case. We are going to choose the model. That is the second step. What are we going to do it with respect to the project lifecycle? And next, this is a very important layer: prompt engineering, fine tuning, evaluate, and adjust with respect to the human feedback. This is what we call it as the reinforcement learning we perform. Madam, one of the madam was talking with respect to the concept of a reinforcement learning. Have a look at it. In the sense, whatever the input we generate or whatever the data we develop, that will be fine evaluated based on the human feedback. It will be fine tuned. The entire process which performs in the operation of a cycle. We call it as the reinforcement learning, human feedback. What are we performing with respect to this? And at last, we are going to adopt, we are going to optimize and augment the data based on the applications what we have performed here. This is the generative AI project lifecycle, and this is how it works. Initially, we choose the scope. Based on the scope, we train the model, right? Choose the model which is existing and take the prompts, right? The prompts are the inputs, evaluate, take the human feedback, fine tune it, again perform this operation repeatedly, and optimize and deploy for the required application. This is one of the example what we do with respect to the generative AI project life cycle. Either it is for the essay writing, for the summarization, or it can for the translation, or for various applications what we do with respect to the generative AI. This is what we are going to do it with respect to this. Next, we are talking with respect to some of the examples. Now we have discussed with respect to the transformer, and also we discussed how the encoder as well as the decoder plays a very important role, why the encoder is required, why the decoder is required, when the encoder is used, when the decoder is used. As I said, for ChatGPT, we use only decoder model. There is no encoding required for the ChatGPT data and all. Right, but when we use some other concepts, for example, as I said, there is no textbook given for the concepts of a generative AI, or for some concepts of, you might have heard the Chinchilla laws, or you might have heard the Bloomberg GPT, or it can be with respect to the proximal policy optimizers, or with respect to the retrieval augmented generation. Nowadays, people are mainly working with respect to the constitutional AI, trustworthiness of AI, responsible AI. These are the trending techniques or the trending technologies where the people are putting lot of research, lot of effort. The students wants to do their research. Please start working on the concepts of RAG, that is the retrieval augmented generation. And also you can make use of a lang chain, or also you can make use of some concepts of a constitutional AI and the responsible AI. These are all some of the trending technologies where the people are finding it very difficult to search. Like we are not able to identify some of the papers. We are making use of only the Cornell papers published by the Cornell, the white papers what we have, right? There is no proper textbook. There is no proper information which we are able to receive it, right? But very interesting and the challenging techniques which is very much required to do research, right? This is what we were talking with respect to the LLM pre-training model. We have a text, and the text will be given to the LLM model. Based on that, it is going to generate the required data. For example, see, we have three different types: auto encoding, auto regressive, and also the sequence to sequence model. In case of an auto encoding, when we have only encoding, you can perform these operations: sentimental analysis, named entity recognition, word classification. The most commonly used models are, you can make use of both BERT as well as the Roberta LLM models for the auto encoding, in a sense only for the encoding mechanisms. And when we talk with respect to the regression, you can perform text generation, and also you can perform behavior identification. You can make use of the GPT as well as the Bloom GPT as one of the LLM models for the auto regressive purpose. And when we talk with respect to the sequence to sequence, we take the inputs in the sequence order and we produce the same. For example, the translation, the text summarization, the question answering, that is the chatbot. For these type of applications, you can make use of the sequence to sequence models, right? This is what we do: auto regressive, auto encoding, as well as the sequence to sequence model. This is one of the applications where we have seen with respect to the LLM, right? I'm just briefing out some of the major applications what we have seen. What is the challenges? What is the, have you all heard of a CUDA programming? What does that CUDA programming indicates? For example, when we were talking with respect to the concepts of a machine learning or deep learning, right? The amount of memory required for training is less, right, than storage, right? For example, if I have a data set of 100 GB, right, it is mainly required for the storage purpose. But for processing, I may take a few. For example, 1 GB or 2 GB of a data is more than sufficient for processing. But when we talk with respect to the generative AI, amount of a data which is required for storage is less, the amount of a data which is required for training purpose is more. In the sense, if I use 20% for storage, I need 80% for training of the data, because here I'm generating my new text, I'm using the LLM. In the sense, the large language model I'm processing, I'm repeatedly performing that operation for the generation of the new text, which requires a huge amount of the memory. That is where many people are working on. That is what we call it as an out of memory error. That is one of the example what we have seen with respect to the CUDA. For example, nowadays our machines are not enough to train our data. For example, we might be using a GPU, right? We might be using the NVIDIA GPUs. We have 100x servers we use, like we use AU servers, like the different types of the servers we use it for training purpose. Some students leave it whole night to train our data, right? Why? Because the amount of a storage required for the training of the data is huge in LLM compared for the testing or the storage operation. That is what we say. For example, if you have a 4 GB data for storage, you need around 64 GB data for training operations, right? That is what we are talking. See, 4 GB for storage, and for training you need around 80 GB. The difference you can find. So huge amount of the data is required for the training process in generative AI or in LLM model, large language model. So how can we do that? How can we reduce the amount of the data required for the training operations? We quantify, we quantize. What is that quantizing indicates? For example, if the data is of 32-bit, it will be represented as 8-bit, or it will be represented as 16-bit. So that the amount of a storage required for the storage of required for the storing that data will be less. That is what we do it using the concept of a quantization. And we have a different methods or a different variations to perform the quantization. That is also one of the examples what we have seen. And this is with respect to the concept of a generative AI. I'll be talking some concepts of fine tuning here. As I said, we were talking with respect to this initial phase. How can we choose the model? How are we going to define the model? Only the encoder model is enough. Both the encoder and the decoder models are required. Now, whatever the input we generate, for example, you might have observed the social media's translators. The translators will be changing even the nouns. For example, if it is given as Satya, it will be, that is the name. Satya is a name what we have taken, but using this translator, it translates and it pronounce it as truth. No one will call truth as your name. Definitely we call Satya as our name, right? Like that, there is lot of challenges involved in fine tuning based on the human inputs. In the sense of the prompt engineering, it accepts the input. Whatever the input it has accepted, that should be fine tuned. Fine tuned in the sense, again, it will be analyzed and it will be evaluated based on the human feedback, aligned with respect to the human feedback. That is what we do it with respect to adopt and the align model. And there is a huge amount of the research taking place with respect to the fine tuning. We can make use of the PEF techniques. We can make use of the LoRa. We can make use of the QLoRa. PEF in the sense parameter efficient fine tuning techniques. For example, you might have heard of some of the BERT or some of the models what we use. Those are all the most commonly used PEF techniques. And next we have a quantized LoRa, low rank adaptation techniques, quantized low rank adaptation techniques, like that different techniques we use to perform all these operations. In the sense, fine tuning in the sense, for example, let us take one examples and discuss that. Have a look at this example. Uh, for the first input, it is showing this as positive, and the second input, it is showing this as negative. But for some examples, you can take. Like, for example, I love this movie, it is positive. I don't like this chair, negative. My sofa is so ugly, negative. Who would use this product? Can you consider it as positive or negative? Some of the sentences we will not be able to consider it as a positive or a negative. How can we fine tune those sentences? How those pre-trained models are used? How the labeling will be done? How are we going to pre-train it? How are we going to fine tune it? Right? For example, you can observe in each and every case, we are going to classify the review as positive or the negative. This is one of the examples what we are going to do it using the concept of a sentimental analysis. We are going to use some prompt instruction, classify based on the text what we have generated, based on the analysis what we have done, based on the summarization what we have done. This is the training, the validation as well as the testing will be done frequently, and it will be fine-tuned several times to get the required output. There's a lot of challenging involved with respect to the fine-tuning process. Now you can observe the output it is displaying as neutral. This is output is displaying as positive. This is not fine-tuned yet. Again, it will be sent back. Again, it will be processed, and the accuracy will be checked. Initially, it will be done it in single task. What is this catastrophic forgetting? For example, this is one of the very important concepts. Catastrophic indicates, for example, if you have a n number of elements, right? Once you train and test those elements, and as soon as we get the new model, we will completely destroy the old model, or we'll completely forget the old model, and we'll start using the new model. That is what we call it as the catastrophic forgetting, which reduces the efficiency of the data what we have taken. That can be avoided by performing the data or fine-tuning operation in a epoch by epoch basis. Epoch in the sense you might have all heard. In a step-by-step process, we'll be going to perform that. That is how the multiple tasks can be fine-tuned using the parameter efficient fine-tuning. That is the PEFT techniques will be used. You can observe, and you need to, whatever the data you have taken, you need to summarize that, you need to rate that, and you need to get the required output based on the operations what we have taken. Fine tuning itself, we have 4 to 5 types. Either it can be TOSF, muffin, cot, natural instructions. You can observe here it has 55 data sets, it has 69 9 data sets, 372 data sets. These are all the categories, data sets, and the task what it has performed for the question generation, for the natural language processing, for the code repairing, for the context generation, for summarization, and for the named entity recognition. All these applications you can observe. The major applications what we have seen is one of the Samsung dataset. That is a dialog dataset. Based on the inputs, it is going to produce the output. This is some examples what I was discussing, what I wanted to discuss with respect to that. And here, each and every data will be evaluated using the evaluation metrics. Evaluation metrics you can use for finding the accuracy. Accuracy will be found using based on the current predictions by the total predictions. And you can take some challenges, and these are now various models. We have 4 different models. Either it can be ROC model or the blue score model. This is some of the models and the metrics what we use for the evaluations. And also we have some benchmarks. Benchmarks are also used for either it can be the glue benchmark, super glue. We have certain formulas. Based on those formulas, we are going to predict. Either it can be considered by considering the unigram, by considering the bigram, trigram, and all. Unigram in the sense single word will be considered. It is called outside. In the sense 4 words and the references 4. That is how you are going to uh, find the recall, precision, as well as the F1 score, accuracy, which is required for the evaluations of the ROC as well as the blue score, right? And in some cases, if you have bigrams, 2 matches, and the 3 references, what we have taken 2 by 3, 2 by 4, based on the matches, you'll be going to compute the accuracy of the respective LLM, that is how it will be evaluated. And the benchmarks, we have 4 to 5 benchmarks. Based on the benchmarks values, we are going to record and we are going to display it. And PEFT, as I said, we are going to fine tune it based on the human feedback and also using the concept of the catastrophic. Right here, you can observe this is how we are fine tuning the given model based on the efficiency. Right, low rank adaptation techniques are also used for the fine tuning of that. This is how they are computing. And low rank adaptation and the QLoRa, that is what I was talking with respect to the quantization. That will be done it here. These are the techniques what they have used for the evaluation processes. And we have, I wanted to show one more. Huh. We have chosen the model, we have done up with the scoping, and we have done up with the alignment. Next, you need to talk with respect to the reinforcement learning, human feedback. For example, you can observe here, right? Whenever we talk with respect to the reinforcement learning, human feedback, for example, I have given the input as knock knock. It should be helpful, can cough, efficiently stop a heart attack. You should honestly provide the feedback. How can I hack my neighbor's Wi-Fi? It should be harmless. hacking neighbors' Wi-Fi is not ethical, even though it is finding it not harmless, but it's not unethical. How will I be able to differentiate? That is what the reinforcement learning human feedback does. In the sense, it is going to identify the toxic language, or it can be the aggressive response, or it can be the dangerous information. By considering these three, it should be helpful, it should be harmless, it should be honest, right? These three features, based on these three features, you are going to define the model behavior and you are going to optimize it and evaluate the model behavior. For example, you can observe human feedback with fine tuning with human feedback has highest accuracy compared to the no fine tuning compared to the initial fine tuning what we have done, right? So whenever we take the concept of reinforcement learning, it maximizes the helpfulness, minimizes the harm, avoids the dangerous topics. In the sense, whatever the fine-tuned LLM we have, we will be taking the human feedback. Based on the human feedback, we evaluate, we fine-tune, and we also design or we also produce the output with respect to the human aligned LLM. That is what we are going to do. As I said, agent we have. Agent is a thing or the object which observes the surrounding environment. Based on the observation, it is going to provide certain reward points. Based on those reward points, it is going to take the action and it is going to represent. This is what the concept of a reinforcement learning we were discussing. You might have observed in the TikTok game itself. For example, if two cross marks are there, based on this, third one should come here. Or if not, it will go somewhere else and it will identify it. Or for example, the another example you can take um, by considering the human feedback what we have collected. You can have a look at it. Every time the human feedback will also not work. Uh, this is there is nothing. My house is too hot. Input I have given to the LLM. Completion you can observe. My house is too hot. My house is too hot. There is nothing you can do about hot houses. You can cool your house with air conditioning. It is not too hot, right? Here, the review points will be assigned based on the review points what we have given. This is actually, we have got 1-1 here, which is indicating this is quite good score compared to the other outputs what I have received. Based on this human feedback, I will align my data and I will produce the output. I will align the data and I will produce the output. I'll revert back, right? This is based on the revert or points what we have got. We are going to produce the result. This is what reinforcement learning with human feedback indicates. Sample instructions for human laborers you can observe. We'll be going to what is the best answer. It should be informative. It should be, you can search the web. It should be best judgment, right? Like that. Some of the positive inputs will be taken, and based on that, the LLM will be trained and rewarded. Training and the reward points will be given based on the human feedback as positive class or it can be a negative class, right? And this is what the policy proximal optimizer I was talking about. With respect to the proximal policy optimizer, for example, if I consider a dog, right? Some LLM will generate dog is a man's best friend. I will give it to the proximal policy optimizer to compute it. Right? It will say furry animal. It is a very ugly animal. It will calculate three different types: value loss, entropy loss, and one is the value loss, policy loss, and the entropy loss. Three values it will be computed. Based on these three value, it is going to predict the output. Dog is a domesticated carnivorous animal. Dog is a small carnivorous. It's one of the most popular pets around the world, which has got the highest entropy. The entropy will become computed using the policy loss, value loss, as well as the entropy loss. Based on these three features, the proximal policy optimizer will reward the points. Based on the rewarding, it will be going to based on the rewarding, it is going to consider who has got the highest points. Based on the highest points, it is going to consider and it is going to provide the output. That is also one of the examples what we have discussed with respect to the proximal policy optimizer. And next, for example, how the LLM were designed. Right. Initially, as I was talking, I was talking with respect to the proximal policy optimizer, and the rewards will be given based on that. And next, some concepts of constitutional AI and some concepts of responsible AI. You can observe. You can observe. Um, we have given thousands of data and the reward model, and we will be scaled it. For example, can you help me hack into my neighbor's Wi-Fi? You can use this app. This is not a constitutional AI, right? It should not be harmful. Even though it is harmless, this is not ethical. So, what does it say? Some of the examples which will be called as a red teaming. Red teaming in the sense, this is one of the concept which is involved behind the cyber forensics, which will be designed to understand. For example, sure thing, you can use this app, no, definitely. The response was harmful because hacking into someone's else Wi-Fi is an invasion of their privacy and is possibly illegal. Hacking into your neighbor's Wi-Fi is an invasion of their privacy. It may also land you in large legal trouble. I advise against it. These are the two proper outputs what we have got using the concept of a constitutional AI. In the sense, hacking neighbor's Wi-Fi is harmful, right? Using the concept of a red teaming, we have got that output. And this is also one concept. And the another concept is with respect to the deployment, with respect to the using the optimization techniques. What are the different optimization techniques we use? Either it can be with respect to the distillation, with respect to quantization, and the pruning. Distillation, the large data will be represented as a small data, or also with respect to the distillation, the teachers trains the student. That is also one of the example of the distillation. Quantization, 32-bit data will be reduced as 8-bit or 16-bit. Pruning, unwanted data will be removed. That is, these are the three different optimization techniques what we use in LLM, right? Um, that is, I just briefed out what do we use, and these are all the cheat sheets what we follow in LLM. And I just wanted to say one more. There is a RAG, retrieval augmented generation. For example, I just wanted to perform some calculation operation. You can observe here, right? When I ask some theoretical questions, it provides the proper answer. And in some cases, I just give some uh, computation operation. For example, I will just give 25 plus 25. In some cases, it will give 50 as an output, but in some cases, it will give 60 as an output. How can I train that operation? How can I perform such operation using a RAG, retrieval augmented generation? Here, using a RAG, we use the concept of internet, or we use the concept of the database what we have, or we use the concepts of the knowledge base what is stored. Based on those concepts, the data system will be trained, the data preparations will be done, and either it can use documents, or it can use wikis, or it can use the expert system, or it can use any of the web sources, and it is going to generate the data. Retrieval augmented generation, that is what we do. And in some cases, we use the concept of a chain of thought for generating the data. And in some cases, we implement PALD. And in the sense, we use the concepts of program aided language design. In the sense here, for example, what is the division of this? It should provide some value, but it is giving now 92.549, which is a wrong. In such cases, what do? We implement code along with the LLM. So for mathematical operations and for some of the programming concepts, implementing code and interpreter with LLM plays a very important role, and it provides the proper output. That is what if people, when you try using chat gpt, nowadays we are getting a proper output for programs, for formulas, as well as for numericals with the aim of, because they have implemented the concepts of PAL here with LLM, right? This is also one of the important concepts. And React, in the sense, reasoning and act. In the sense, by using the concept of analysis and the reasoning, we are implementing the LLM. This is also one concept what we have. It has four concepts: question, thought, action, and observe. Question, thought, answer, and action and observe. Based on these 4 points also, we use the concept of an LLM. And these are the major applications what we have seen. Responsible AI is one of our concept. With respect to responsible AI, we are finding it challenging in identifying the toxicity, hallucination, and IPR. Hallucination in the sense imagination of the wrong results, right? Those three challenging tasks we have, and most of the prompt engineers are badly working on these challenges. And as I said, there is no proper textbooks or there is no proper inputs we have. This is one of the white papers which I referred, that is attention all you need for the self-attention mechanism. These are all the white papers what is given by ARXIV and some papers we have with respect to the overview. You can find a lot of white papers, but there is no textbook. If anybody is interested, they can start writing the textbook by using these white papers. And we have a Bloomberg GPT, which is mainly used for finance. And we have a zero optimization. That is what I was talking about, distillation process, pruning and all. That is what the paper given by zero. And we have for pruning, we have some other papers for mainly for pruning. And for this is for the low rank adaptation. By using all these, I have done some slides. And we have some more papers. Uh, for QLoRa quantization, and we have some papers for to generate the better data and proximal policy optimizers. That's what I was talking with respect to the three different types of losses: quality loss, value loss, entropy loss, and all. And we have some papers for React, right? Reasoning and act. This is also what they have given, right? Well, these are all the images which is taken from those papers only, right? But the number of pages what we find with respect to white papers are huge compared to the normal papers, so it takes more time for us to sit and come out of the outcome. If any of you are interested, just refer some of the papers given by the Cornell for the concepts of generative AI. The major applications we have seen, the translation, summarization and all, for the generation of the data, text and all. These are the major applications what we have seen using the concepts of generative AI. This is some of the research topics. Ongoing research is going on with respect to the scalability, with respect to the LLM capability and the responsible AI, mainly with respect to toxicity and hallucination. These are all the various concepts what we can find with respect to LLM. Dear all, any doubts you have?
Okay, any questions from audience? Ma'am, very less time. You have to give lot of information, madam. Very nice presentation, madam.
Madam,
Yes, sir.
I think we should have given you 3 hours, madam. Excellent.
Initially, I thought of asking, I thought of starting by 6 to 9.
Madam, instead of that, what we could have done is for 3 days we could have made, madam, your talk. Doesn't matter. Doesn't matter. We will be utilizing your resource, madam.
Thank you. Thank you very much.
Thank you, madam. Thank you very much.
Okay. Okay.
Excellent.
Thank you, one and all.
Now the session is open for the delegates. If you have any questions, you can ask madam, or if you have any questions you want to post to madam by mail, also you can do. I think
Yeah,
someone was
you can
asking.
contact me anytime. You can text or contact me anytime. Definitely I'll give you our insights
Yeah,
towards the
yeah, yeah,
concepts
yeah.
because I'm working in this field from last 10 years. So quite habituated. Like
Lot of inputs we could see, madam. Lot of inputs we could see. Someone wanted to ask something.
yeah, please, if
Delegates,
you have any
yeah,
questions.
yeah. Please, if any question, please ask, madam.
Audience, any questions?
Someone wanted to ask some question.
Madam.
Ma'am, good evening, ma'am.
Okay.
Yes,
Yeah,
good
please.
evening, ma'am.
Ma'am, first I thank you, ma'am. You give a very lot of information. Really I thank you, ma'am. Could you
Yes,
please
ma'am.
explain the NLP about, ma'am? I need a one more
Huh.
session about, ma'am. Could you please mail contact,
Yes.
ma'am? Because you gave a lot of information about some
Yeah,
other things,
definitely,
AI, like
definitely.
uh,
Ma'am,
yes,
natural language processing, NLP is one of a broad domain what we use with respect to AI and ML. For
NLP.
example, whatever the concepts I spoke today with respect to LLM, right, or with respect to in-context learning, with respect to zero shot, one shot, or for example, if you are using tokenization, if you are using positional embedding, these are all the topics what we use with respect to NLP. In the sense, natural language processing. For example, if you are using your linguistic language, any of the Indian language, what we process and what we generate for the translation, either it for the summarization or it for the information retrieval, right? These are all the basic operations what we perform. Natural language processing is a domain similar to computer vision, similar to automation, similar to image processing. Like that, we have various domains in the concepts of AI. They are all the umbrellas what we see. This deep learning, machine learning, and AI, generative AI, are the technologies, right? And we use those technologies for various applications of NLP. For example, you might have seen whenever we talk, we use English in between our local languages. That is what we call it as a cross-lingual processing. Cross-lingual processing in the sense usage of our native language along with the English, along with some different languages. Processing of those data using the tokenization or the architecture, what I explained, right? That is what we call it as a NLP.
Excellent, ma'am. Really thanks, ma'am.
Okay,
Thank you, ma'am.
any other questions from audience?
Hello, madam. Good evening.
Hello, sir. Good evening.
Ma'am, how does actually a ChatGPT generate data? Is it again a generative AI only?
Yes, sir. That's what I was talking. It uses only the decoder model. It will not use the encoder model, only the decoder. Using the decoder, auto-regressive model, the chat GPT generates the data. That is what I was talking here. I'll show you that slide. Here, we were talking with respect to the concept of a encoder models, encoder decoder model, and decoder only model, right? Along with this, I said here we perform only encoding operations. Here we perform only decoding. Both encoding and the decoding operations are performed. What does that encoding performs? It accepts the prompts with contextual understanding and provides one vector per input token. That is what encoder do. In decoder, whatever the input it has accept, it generates the new tokens, right? That is what the chat GPT do. Chat GPT, based on the input what it has accepted, it generate new tokens, right? How it generate new tokens? With the help of web sources, with the help of a databases, with the help of the documentation what we have fed it into the chat GPT. Based on that, it perform a decoder only model. It is completely based on the self attention mechanism. Self attention mechanism, this is what I was discussing with respect to the self attention mechanism. Based on this complete self attention mechanism, the concept of a transformer and the concepts of the LLM model, for example, the ChatGPT is also designed.
Okay, right, madam. Ma'am, I have one more doubt.
Yes, sir.
Actually, I'm working at present on network security and cryptography. So,
Oh, okay.
which actually AI will be actually can be applied here that I'm not getting exactly.
Hmm.
Is it again there will also be generative AI should be required or how it is? I'm not
For
exact.
cyber security and cryptography, like we are not using the concept. You can like, explore more on using the concepts of blockchain.
Okay, because it's a blockchain, right? Okay, fine, fine.
You can use block. You can extend it using blockchain.
Okay, okay, right. Thank you, ma'am. Thank you.
Okay, sir.
Any other questions from audience?
Please feel free to ask if you have any questions.
Sir, I request you, sir. Please, again, the session please conduct on ma'am itself about the image processing, sir. Because
Don't worry,
ma'am give, yeah.
don't worry, madam. We will
Okay.
make use of Madam Simantini for future workshop. Okay, don't worry. We will plan. We will plan.
Thank you, sir.
Definitely, ma'am. Since my domain is on computer vision, I can talk with respect to DIP, no issues. Definitely, I'll do that.
Thank you, ma'am.
Okay, thank you so much.
Thank you, madam. Thank you very much
Thank
for
you.
your
Thank you,
time
everyone.
and your efforts in bringing more things in a short period of time. However, we will have an extended session a little later. Thank you very much, madam. Thank you very much
Okay,
for
thank you. Thank you, sir. Thank
joining
you, everyone, for
numerous.
providing an opportunity. Thank you, sir.
Thank you. Thank you, madam. Dear all, we are coming to the end of the 3-day workshop. On behalf of New Research and Innovation Society, I thank one and all for joining us and listening to the speakers' lectures for all the 3 days. And you have been very actively interacting with the speakers. And I hope you have learned many things and make use of these things and kindly give us feedback separately also so that we can provide or we can organize some more informative sessions on similar topics. I welcome you all again for the future programs, and we hope you are all aware of the international conference to be held in April, and we this time we are going to conduct offline for the third day. So we expect papers from you, abstracts from you for autumn 2024. Kindly visit website and submit your papers, which are to be published in indexed, including SCI extended journals, Scopus journals, elsewhere Springer, and so on. So make use of the opportunity, submit your paper abstracts so that we will meet in the international conference to be held in Chennai in the Hotel Royal Plaza. Thank you all. You will be getting your participation certificates on or before Saturday. Okay. Thank you
Sir,
all. Thank you very much.
today we will send, sir. Already prepared.
Okay, sir. Okay. Okay.
Today we will
Okay.
send. Today we
Okay.
will
Okay.
send.
Thank you. Thank you, sir. Thank you.
Okay, thank you. Okay.
Thank
First
you
of
all. Let Sir, Professor, you can say a few words.
yes, sir. Yes. First of all, thank you so much for all participants. And our team members, Balaji and his team. Balaji, thank you so much. Deep, Kamraj sir. 3 days very successfully conducted. The whole first day also a very fantastic speech from Ranjani madam, Sri Ranjani madam. Ma'am also has given lot of information in a very less period. My special request, ma'am will prepare one good book about her research. That's my
Thank you, sir.
another one more doubt also, madam. I have. You were
Huh?
showing one Venn diagram actually.
Huh?
AI is a whole set.
Huh?
Then machine learning is one of the subset.
Huh?
Then deep learning is also the another subset.
Huh?
Already lot of people are doing research. You know that machine learning and deep learning.
Huh?
From your view, I think machine learning people and deep learning people is shifted to AI. Is it correct, madam?
No, sir. They have shifted. Like that's completely a different era when we were using a concept of a AI or when we were using the concept of a deep learning and machine learning. Right now, the era has completely changed. From last 2 decades, we were using those things, but now we are mainly focusing on the concepts of generating AI. No, like nobody can imagine like we can sit and generate newsletters, everything, whatever. Each and every people are generating music, poems, This is they are only make using of the concepts of AI, right? Not using deep learning or machine learning. This is completely different. Only using an AI, they are implementing the concepts of generative AI.
Okay, okay, madam. The image showing like this. That's why I'm
No,
telling.
the image is like that. That's a Venn diagram which is indicating
Yes,
AI is a broader tool.
yes,
Under
madam.
AI, we have the
Because
concepts of machine learning and we have the concepts of deep
yes,
learning.
in mathematical language, these two are belongs to AI.
AI.
For example, A
Broader
and
umbrella is AI.
yeah, A and B is belongs to this whole set. AI.
Yes, sir.
Yes, madam. Yes, madam. Okay, madam. Thank you, madam.
Okay, sir. Fine.
Uh,
Thank you so much.
okay, thank you, madam. Thank you so much. Sir, please close the session, sir. Please.
Yeah, I once again thank all the 3 days speakers and particularly today's speaker who took a lot of things she brought to the benefit of the delegates. We will definitely have Madam. Uh, we will use the resource of Madam. Separate workshop using Madam for
Definitely, sir.
advanced, yeah,
Definitely.
for advanced learning of the delegates. Thank you, Madam. I
Thank
thank
you so much, sir.
I thank once again all the delegates, Professor Bala Muralidharan, for coordinating all the 3 days workshop. Mr. Balaji, our technical team leader, who has been with us on all these 3 days in successfully conducting this workshop. I thank the delegates for their wonderful cooperation in this regard. Uh, Thank you all. Good night.
Good night, sir. Thank you so
Good
much.
night, madam. Good night. Thank you.